In this lecture, we're going to start and learn about container adapters. And these are containers we can use to customize and restrain the interface of some sequence containers in the STL. And those are mainly going to be std vector, std list, and std deck. And we are going to use these as a base and provide an interface that is fit for a given purpose. We will use these base containers to set up std stack, std queue, and std priority queue to have some kind of interface that we desire in our C++ program. Now, what is a stack? A stack is a container that has first in, last out semantics. And what do I mean by that? Well, the elements that gets in first gets to get out last. We're going to have something like this. For example, if we put in a 1 and put in a 2 again and put in a 3 and put in a 4, when we get to need to remove elements, we will go through a single method, mostly called top, and that's going to give us the element that was added last. So if we try to remove an element, we will get the 4 removed. You're going to see that it is the last thing to go in that goes out first. If we remove again, we're going to take out the 3. If we remove again, the 2 is going to go. And if we remove again, the 1 is going to go. And this is a defining feature of stack containers. The first thing to get in is the last thing to get out. And this is useful, for example, in function calls. The first function to be pushed on the stack is going to be the last function to be popped off the stack. And the C++ runtime is going to use stack containers to organize how functions are called in your C++ program. And this is really cool. You can use the stack container adapter if it makes sense for your C++ application. Another container adapter we will have a chance to look at is queue. And this is different in that the first thing to get in will be the first thing to get out. So you can think that we can add things from one end. So for example, we can consider that on the top we have input, and that at the bottom we have output. And things are going to be coming in from the input and going out from the output here. So if we add something, for example, we can add a 1, we can add a 2, we can add a 3 and a 4. This is going to put in our data. But when we get to remove the element, we will be removing from the bottom here. So if we remove 1, 1 is going to go. We're going to be left with 2, ready to be popped out the next time. If we remove the 2, the 3 is going to become the next element to be removed. You see that we have added a 5 at the back, and this is the order things are going to happen in a queue. Another thing we have is a priority queue, which is going to work exactly like a queue, but it is going to order elements and give them priorities, and the element with higher priority is going to go at the end and be ready to be popped out the next time somebody pops out an element from the priority queue container. Now, you must be asking, why would I need things like that? Well, a priority queue makes sense, for example, if you have a resource in your C++ program and you need to decide who will get first access to the resource. You can store elements containing for your resource in a queue or a priority queue. And the first thing to be popped out of your priority queue is going to get the resource. So you can really use these things to allocate resources in your C++ program. And this is going to work really well. Now, these containers will be reusing sequence containers under the hood. And good candidates are std vector, std list, and std deck, as we have seen. Let's see how our stack, for example, could work. A stack is going to be adding elements from one end, and the elements are going to be popped out from one end. And the first element to go in is going to be the last element to get out. So for example, this one here got in first, but it will get to go out when all the other things on top of it have gone out. This is the setup we have for a stack container. Now, we can achieve the stack interface by using the sequence containers we have learned about. But those containers need to support this interface to really be used as stacks. So we need a back method, which is going to be used to read elements from the stack. We need a pushback method, which is going to be used to put data in the stack. And we need a popback method, which is going to be used to remove things from the stack. We have a few containers that support this interface. We can either use std vector, std list, and std deck. And we can use these things under the hood to set up a stack interface. And the STL is going to give us this flexibility. If you want, you can come back to the documentation and look at these things. So for example, we can look at container adapters here, and we can open up the stack documentation. We are going to be able to read all about this here. It provides a last in, first out interface. And if we go down, we're going to see that we have a top method to access the top element from the stack. We have a bunch of methods to put in data. So we have a push, which is going to add an element to the top. We have in place, which is going to put an element at the top and build it in place. We have pop, which is going to remove the top element. And we have swap to be able to swap contents of stack objects. And you can see that we can achieve a stack under the hood by using std vector, std deck, and std list. Basically the same thing we saw in the slides. Now let's look at how a queue is going to be set up in memory. We are going to be putting data in the queue from one end and getting data out of the queue from another end. So we need something we can manipulate from both sides for a queue. And we need a back method, a front method, a pushback method, and a pop front method to support this interface. If we look in our sequence containers, we're going to see that list and deck are good candidates. std vector is going to be ruled out because it doesn't have a pop front method, so this is something you should remember. We can also look at the priority queue container adapter. It is going to be bringing things in from one end and taking them out from another end, and it is going to decide which element gets to go out first by using a priority mechanism. To support the interface here, we will need a bunch of methods. We need front, back, and pop front. And here are a few of the sequence containers that we can use as a basis. std vector and std deck can be used. And that list is going to be ruled out because it doesn't have random access iterators, which are required for this to work. And how do I know this? Well, I read the documentation. So if I come here to the documentation for priority queue, I am going to read all I can about it. But if you go down and look at the container that we can use as a basis, these are the requirements. It needs to be a sequence container, and it needs to satisfy the requirements of random access iterators. So list doesn't provide a random access iterator, and it won't be able to be used as a basis to set up the priority queue interface. Okay, so this is really all I had to share as an introduction to these container adapters. They are not containers themselves. They merely modify the interface provided by low-level sequence containers like vector, list, and deck to provide the interfaces needed to make our container work like a stack, work like a queue, or work like a priority queue. We're going to stop here in this lecture. In the next lecture, we're going to focus on the stack container adapter. Go ahead and finish up here and meet me there.